Hello, good morning. This is Zander Chithalen, and this is my presentation on fatigue. What is fatigue? Fatigue occurs when an object weakens and then fails after many repeated cycles of loading and unloading stress. Fatigue is caused by micro imperfections in every material after thousands or millions of times doing its job. It finally cannot take the same force again and begins to fail. As the picture on the right shows, there is an initiation crack, and then there's fatigue cracks of propagation that slowly increase in size as the material is more worn and worn down, and then there is fast fracture, which shows when the object finally fails. Why is testing for fatigue important? In order to test for fatigue strength of materials, several identical samples of one material are produced in advance and placed in what we use an RR-Moore fatigue tester. This type of tester holds the sample between two machines that unload and load stress onto the material while also putting it through tension and compression. The tests are used to generate crack growth data, identify critical locations of fracture, and demonstrate the safety of material structure that may be susceptible to fatigue over long periods of time. These tests are also important because they're used in range components throughout full-size test objects such as automobiles or airplanes. One example is airplanes, as the picture on the right shows, one going through 2 years of fatigue testing to ensure that the plane is safety regulated. How do you draw a SN curve? There is a video with the link that I would recommend watching because it helped me explain my step process. Unfortunately, I was rushing and did not find how to play it in the presentation. First, how I draw my SN curve is I use the specific graphing paper as shown on the picture to the right to draw the curve. Remember to draw the curve after you receive all your significant digits and numbers from your testing. I start my curve at the 10 to the power 3 number of cycles on the x-axis. This is where the metal will begin to fail. Mark the knee of the graph, usually around the 10 to the power 6 number of cycles on the x-graph, at the height of the endurance limit that you are given on the y-axis. The line between the first point and the knee of the graph is more of a best fit line for wherever you have found your measurements. Then connect the lines and complete the graph. All ferrous metals should have a double straight line as shown on the right, while aluminum will have more bend to its curve. How to discover stress coefficient from charts and graphs. When you examine an SN curve, the starting position at 10 to the power 3 cycles is the S max, which is the highest amount of stress applied to the object and also the highest point of fracture strength in the material. The line of best fit that connects the S max to the knee of the graph shows the decrease in fracture strength of the object. The knee of the graph is the beginning of the endurance limit, also known as the SN or SF, depending on the graph used, of the object, which is the little corner of the graph. If no stress is ever added to the object at this limit, the object would never fail. But if there is any increase at all, the material will split and the object will ultimately fail. How to calculate the fatigue strength for a specific number of cycles. In this example, I used the 1045 steel in the picture to the left, and I have calculated some given values from the chart to be used in this equation. First, we must use the equation where B equals negative in brackets log of S max, which is the first point, divided by Sn, which is the endurance limit, divided by log times the number, times 2 of the number of cycles. Once you found B, you then sub it into the next equation to discover the specific fatigue strength of the material at the given number of cycles, which is fatigue strength equals S max times 2 times the number of cycles to the power of B, which is found above. I did this example and calculated it to be 44.9 KSI, which is around the line of best because it is a best fit curve and not a specific number for each amount of cycles. The estimation for the number of cycles in a certain applied stress is a lot more simple since it's an estimation. In this example, I used the red curve at a number of cycles to find at the KSI of 20. First, you must locate the stress level on the y-axis. Then you must trace a perpendicular line from the 20 KSI position to the red curve and place a point. Then at this point, draw a line vertically towards the x-axis, and wherever the line ends up is the amount of cycles you have when the material has that much KSI applied to it. In this example, I received 8 units of 10 to the power 6 cycles, which is the estimated value that was needed for the applied stress. Thank you for watching my presentation on fatigue.